2, multiplying and dividing rational expressions. So again, like I said, we're going to use fraction rules. So when we multiply across, which means we take the numerator times numerator, which is just top times top, bottom times the bottom, which is denominator times denominator. So for our first example, I would times my tops times my bottoms. I would get 60 over 40, and then your last step is always reduce. So you would math frac that. And when you math frac it, you're going to get 3 over 2. Okay? Should give you 3 over 2. Everybody try it. Let's take a look at the dividing. Dividing says you need to reciprocate the second fraction. That means the fraction after the divide sign is what that means. The second one means the guy after the divide sign. It's never the first one that flips. So reciprocate just means flip it upside down. So that means this guy needs to flip upside down. The minute we do that, the divide sign changes to a multiply. So now, this guy is going to look like this. Negative 3 over 5 timesing by, the divide turns to a times, 20 over 3. Now we go back to our multiplying rules. We multiply tops, multiply bottoms. So here we're going to get negative 60 over 15. And 60 over 15, 60 divides by 15 evenly. So that's going to give us an answer of negative 4. Okay, give it a try. Now, what did you notice the way I wrote that down? What do you notice about the second one when I wrote it down? I brought the negative to the top. The negative didn't move. How come? Because even though he looks like he belongs to the 8, he doesn't. He belongs to the fraction. So what that means is, if there's a negative sign, it will always float to the top in the end. Okay, now just count your negative signs. You have 2 negatives. A negative times a negative gives you what kind of answer? Positive always. So you disregard those negative signs. So we know we're going to get a positive answer. So we multiply the bottoms, multiply the tops. We're going to get 24 over 48. And that divides evenly. So that's going to give us 1/2 or 0.5. Okay, check. Alright. Now, you're going to notice it says cross-simplify if possible. This is what I mean by cross-simplify. Let's go back to this middle one. If I take this middle guy, I've got negative 3 over 5, and I'm going to times by 20 over 3, because I have to flip that one. By cross-simplify, it means look at the numbers that are diagonally away from each other. If they can reduce them. Because if they do, it'll make the reducing part in the end easier. So, for example, the 3 and the 3 divide by 3, right? So these both divide by 3 and become 1s. Okay? The 20 divides by 5 evenly. So divide them both by 5, I get a 1. Divide him by 5, I get a 4. Okay, well, what was my answer I got? I got a negative 4 for an answer. Well, if I multiply tops and bottoms now, I'm going to get negative 4 over 1, which is just negative 4. Okay, so if you prefer to do the cross-cancel stuff, by definite, for sure, absolutely do that. Okay, we'll simplify things for you. If you look at the left-hand side one here, the far left, this guy can cross-simplify as well. The 10 and 5 both divide by 5, I can get a 1 and a 2. The 12 and the 4 both divide by 4, becomes a 1 and a 3. What was my answer? 3 over 2. Okay, so it does it quicker for you if you understand that cross-simplify rule. Okay, now we're going to go putting x's in it. We're going to put some variables in this stuff, so we're going to use rational expressions. But we're going to use all of these rules with our rational expressions. So, taking a look at these, it says, now we have to remember how to multiply and divide variables and exponents. So, when we multiply, we add exponents of the like variables. Like variables just mean it's the same letter. Okay, it's the same letter. When dividing, what are we going to do then? Opposite, subtract. Now you're going to subtract exponents of like variables. Okay, that's what we've been doing. So if I take a look at this first example, I've got c squared on top, I've got a 5d, and I have a 10, and I have a 2c. Well, if I use my cross-simplifying rules, 5 and 10 both divide by 5. He becomes a 1, he becomes a 2. Now I can take my c's. If you look at c, I've got a 2 on this c and a 1 on that c. I need to subtract them because they're top and bottom. So I'm going to subtract them, which means I'm going to have 1 left over. So that means the guy on the bottom is going to disappear, and I only have 1 left over on top. So now if I multiply tops and bottoms, I'm going to, don't forget you got a hidden 1 in front of that C. So you're going to take 1 times 1, will give you your 1. Then you've got C and D side by side on the top. And on the bottom you get 2 times 2, which gives you 4. Now we could, that's your final answer, that's your lowest terms. We could have solved that the other way, okay, where we just multiply tops, multiply bottoms, then simplify. That also works. If I did it that way, all you do is you slam the sides together. So I'm going to get 5D sitting beside the 6, or the C squared. So it would look like this. 5C squared D on top. The bottom, you'd slam them together. If they're digits, you multiply them. So 10 times 2 would give me 20, and I have a C on the bottom. Now don't forget, that's a C to the 1. Now you just simplify. If there's digits, meaning coefficients, you put them in the calculator, 5 divided by 20, and then math bracket. That'll give you 1 over 4, which I have here, 1 over 4. Okay? The C's, you're going to subtract the C's and get a C1 left over, which is what I ended up with. Okay? So if you want to, if you don't like this cross-simplify stuff, you can do what I did here on the left. Okay? You can write it out together and then simplify it from that point if you like. Okay? That also works. So how do we do this when we actually have rational expressions? There's some rules we're going to follow first. First one, always your favorite F word in math, factor. You need to be able to factor, if possible. Sometimes you can't factor it, and that's okay. But if it's possible, you need to factor them. Define the variables and your non-permissible values. That's the one thing we forgot over there. Which letter is on the bottom, C or D? Which letter started on the bottom? C did. So that means only C needs to have a restriction. D can be anything because he's on top. So we need to tell us that. Okay, you got to state that. So I would say, okay, well, D can be anything. D any real number. But C can't be. What does C have to be? What can't he be? 0, right? Because if I take 0 times that 2, it becomes 0 on the bottom, right? So then C cannot be 0. D can be anything, but C can't be 0. So again, you only do it to the variables that are on the bottom. That's what needs to have a restriction. Then we cross-simplify by removing common factors if possible. This is what we were doing when we simplified before. So if we take a look at this question here, that they give us, question B, can I cross-simplify anything? Does anything cancel, is what cross-simplify means. The x minus 1 brackets, right? These guys are identical, they cross-simplify. Do you see anything else that'll simplify? You got a 4x and a 2x, right? So the 4 is going to divide by the 2 and become a 2, and the x's are going to disappear. Okay? Does anything else simplify? No. So now what we're going to do is you have to write it as a final answer. So if there's digits on top, you need to multiply them. So I need to multiply that 2 and 5. So I'm going to get 10. And you need to sit it beside the bracket sitting left over. So the bracket left over is an x plus 3. Over here, on the bottom, what am I left over with? Just a 3. Good. Now, let's do our non-permissibles. Don't forget, your non-permissibles come from the original. So I have to do this and take a look at my original. And it's always the bottom ones. Okay? What can x not be on the left? A 1. Good. So x can't be 1 on the left. What can't he be over here? A 0. So x can't be 1 and it can't be 0. Okay? Pretty simple stuff so far? Okay? So this one says, if we divide, we're giving us a hint here. It says, after factoring, you need to define your variables first, which means put your non-permissibles, that's your NPVs, your non-permissible values. Okay? That means in the entire expression, you want to do the numerator and denominator on the right-hand side of the dividing sign. Now, why do you think that happens? Why do we have to do to the bottom and the top of the whole right-hand side of dividing? Because I flip it. Right now, the 6 originates at the bottom. When I flip it, this guy goes on the bottom. So when you divide, you need to do the non-permissible values of both bottoms and the top one on the right. So it's easier to remember which one you don't do. Which one do you not do the non-permissible of? The one you don't do is the guy on the top left. He's the only one that you don't worry about a non-permissible of when you're dividing. Okay? So when you're dividing, everything does a non-permissible but the top left. Okay? So if we take a look at this guy, is he in factored form? Our first expression? Yeah, he's as low as he goes for factored wise. Now we just have to simplify. We can't simplify, remember, until we flip him. Okay, is there any variables in the bottom that I start with? No. But when I flip them, when I flip this guy, I have a 5n squared on the bottom. My n is on the bottom now. So that means that this guy needs a boundary. He needs a restriction. What can't that guy be? He can't be 0. So we would say n cannot be 0. Okay? You know, we're only talking about the n on the bottom right. We don't care about the n on the top left. Okay? We're talking about the n on the bottom right. All right, now we're just going to simplify first, or simplify further. So, is there anything that cross simplifies? Okay, 5n squared. Well, first of all, that 5 is going to become what number when it gets squared? What's 5 times 5? 25. So that's not actually 5n squared. That's 25n squared is what it becomes. If you just leave it as a 5n and then it's squared on the outside, you'll take your 5s off, but you're going to forget there's another 5 down there.
Is that because of the brackets?
It's because of the brackets.
So the one at the top left.
Yep. Yes, the top left one is still the same. So now, if I want to cross simplify this guy divides by 5 and gives me a 5 left over. This guy divides by 5 and gives me a 1 left over. I can subtract my n's. n4 subtracting n2 gives me how many n's left over? n squared left over, right? 4 subtract 2 is 2. So that means the guys in the bottom disappear, and this becomes n squared on top. That's all that I have left over. On the top right, bottom left, they both divide by 2. Divides by 2 becomes a 3. Divides by 2 becomes a negative 1. Now I times my tops and times the bottoms. I will do this again without the canceling part, and then I'll reduce it. Okay, so if you find this part confusing, I'll do it the other way. There's 2 ways to do it. Okay, so now you take 1 times 3 to give you 3. On the bottom, oh, sorry, you got your n squared still. He's on top. The bottom's a negative 1 times 5 to give you a negative 5. Is that your proper answer? No. Your negative needs to go where? The top. It's going to float to the top. So you're going to have negative 3n squared over 5 is your final answer. Okay, because your negative sign will float to the top. Okay? So I'll give you a minute to write that down, and then I'm going to do it the other way. Okay? Okay, I put a non-permissible value down. Now I'm just going to do it the other way. Okay? Here's the long way. Again, I need to flip those guys. So I'm going to have 5n4 over negative 2, timesing by 6 over, and now I'm just going to put that 2 in. 25n squared. Okay? So that's what I start with. Now what you can do is you can combine your top, which means multiply it, combine the bottom by multiplying, and then you're just going to get one fraction again. Then you reduce that fraction. So on here, I'm going to multiply the 5 and the 6. So I'm going to get 30 and exponent 4 on top of, on the bottom I multiply those, I'm going to get a negative 50 over n squared. If you find it easier to do it this way, sometimes it's easier if you see the linearness of it. That's fine. Again, your zeros will cancel. 3 and 5 don't reduce. They'll stay as 3 and 5. Now just subtract the n's. And you'll get n squared. So my final answer will be 3n squared over negative 5. And again, your negative will float to the top. Okay? Whichever way you find easiest is the way I'd like you to do it. If you found that cross-cancel stuff too confusing, do it this way. Okay? Okay, let's take a look here. Again, before we start, we've got to do non-permissible values in the factored form. This guy's factored, so I need to do non-permissibles. I do it of everything except the top left, because it's dividing. Because remember, this guy starts on the bottom, but when you flip it, this guy goes to the bottom. So you have to do non-permissibles for the whole right-hand side, and then just the bottom on the left. Okay? So I've only just scribbled him out right now, just for a moment. We're still going to use him, but I just scribbled him out so you don't look at him for a non-permissible. So right now, non-permissible, the bottom here, that x can't be 0. This x up here, what makes him? -1. So x can't be -1. What about this guy? 2. Good. X can't be +2. And what about that little x sitting in front? 0 again, like this guy, okay? All right. Now I'm going to erase all my scribbles and start simplifying. So when I simplify again, I'm going to flip the right-hand side. So my left stays the same. I get 2x + 1 over 3x timesing by x - 2, all on top of 4 times x + 1. All right. What cancels on these ones? The x + 1's good. What else cancels? Well, 2 and 4 reduce. They both divide by 2. He becomes a 1. He becomes a 2. They both divide by 2. And then your x's here that are sitting side by side, they're going to disappear as well. Okay, so there's an x by itself on the top and an x by itself on the bottom. Okay, so they're going to disappear as well. Now all we do is we write whatever is left over. So what I have left over on top is just a 1 sitting out front of x - 2. So I've got my hidden 1 in front of x - 2 on top. On the bottom, all I have left over is 3 times 2. That's all I've got left over. Okay, so I'm going to multiply 3 times 2. I get a 6 in the bottom. That is my final answer. Okay, you cannot go any further than that. Okay, you might see it written this way. Again, any number on the bottom can be taken off and put as a fraction beside it. So this could look as 1/6 times x - 2. You might see it written that way, and that's okay too. So if this guy here, he's a 1, that 1 is the numerator, the top number of the fraction. If that guy was a 5, it'd be a 5 over 6 over there. Okay, same thing that we did with our logs. Any number on the bottom could sit out front as a fraction. Okay? All right, let's take a look at a few more examples. Give this guy a try. What are your non-permissible values for this one? You guys give it a try on your own, then we'll see what you come up with. Okay. Is the answer A? No, what's wrong with A? What's it missing? The +4. Good, so it's not A. Does B have everything? Yeah, B has everything. How come D is wrong? It includes the 0. I don't need to include this guy as part of my non-permissibles. Okay, remember, that's the only one in division that you don't use for non-permissible. Okay? All right. Find the error. We always have find the error questions. So we have 2 find the error questions here. I want to give you a couple minutes to look at those, and then we'll take it up together, okay? All right, what'd you find on B here? Well, let's check our non-permissibles first. These guys on the left-hand side do not have to be factored. How come? Because they're monomials. Okay, they're just small. So because they're one-term monomials on top and bottom, you don't really have to factor those much. So if we take a look at those guys, what can A and B be here? 0. So these guys are right so far. Okay. Now let's see what they've done. Well, they flipped this guy correct. That's okay. They forgot to put the negative sign on top. The negative's going to disappear anyway, so that's fine. Now, if they get rid of the 2, this guy down here becomes a 2. If they get rid of the 5, this guy up here becomes a 3 because those become 1s, correct? All right. Let's see how many A's we would have on top and bottom. So if I just slam it together, I would have A squared on top, and I would have B3 on top with a 3 sitting beside it. Then on the bottom, I would have a 2, this 2 here. Then I would have a 4, and on the bottom here, I have a B. So now what we have to do is we have to see how they simplify it. So first of all, can 3 divide by 2 or times by 2 and get a 6? No, so the 6 is wrong. They've got that part wrong. Over here, the A's, when I subtract the A's, what happens when I subtract them? I get A - 2. Well, remember, when you subtract or add them, they automatically go to the top. So he's going to be a negative 2 on the top. Where should he go to be a positive? The bottom. So he's going to be an a plus 2 on the bottom. Okay, so that should be a plus a squared on the bottom. Over here, we're going to subtract those. And what happens there? It becomes b squared. So on the bottom, I'm going to have a squared, b squared. So their solution is completely wrong. So what you should have, the only thing that's going to be left on top, b squared will be on top. This guy's going to be on the top. This guy will be on the bottom. So, because remember, when you subtract them, they go to the top first. So what it would look like originally. This is what it would look like. This guy would look like this. 3a negative 2b squared all over, hang on, a negative 2b squared all on top of 2. That's what it would originally look like. Now you've got to take that a squared to the bottom to become positive. So your final answer is going to look like 3b squared on top of 2a squared. So they had the complete answer wrong. 100% wrong. Okay? They got their steps right, but their answer was wrong. Do you see why it works that way? Yeah? Okay, let's move on to B and see what you found in B for an error. So on B, let's see what they factored out. So they got rid of this 5 and the 15. You should have a 3 there. They got rid of 1x plus 5, but down here I've got 2x plus 5s. Okay, that's what that squared sign means. It means I have 2 of those brackets. So that just means that only one bracket can disappear. You still have 1x plus 5 bracket left. On the top, your 8 divides by the 2 becomes a 1, the 8 becomes a 4. Now, if you look at your x's, you're going to end up with this now. So left over, we're going to end up with this. You're going to have 3 times 4, 12x on top of x squared in front of x plus 5. Now, can this simplify further? There's one thing you can do. Only one thing. What is it? Reduce your x's. So these you're going to subtract. You're going to get 1 subtracting 2 is a negative 1. So it would be this, 12x negative 1 over x plus 5. Can I leave it like that? No, you never leave negative exponents. So your x negative 1 is just going to stay down here in front of your x plus 5. So this x is in the wrong spot. It should be down here in front of the x plus 5. Okay? Does that make sense why that happens? Okay, what are the non-permissible values? Now we've got to find our non-permissibles. We forgot to do that. So remember, because it's multiplying, your non-permissibles only come from the bottom. So on the bottom here, what do I have? A negative 5. Well, that's this guy only. Did they ask for this guy too? Do I have to worry about him? Yeah, you do. You have to worry about that x squared. What can that x be? 0. So they forgot that x also can't be equal to 0. So they forgot a couple things. This will be their final answer. Well, that'll turn to a final answer with the x on the bottom. That's going to move to the bottom. But then they forgot the non-permissible as well. Okay, so they forgot a couple things there. Let's take a look at the big bottom question. On this big bottom one, first thing they had to do was factor it. Okay? So let's see if our first step, the factoring step, is correct. Okay? So the first step is always factor it. Well, this little squared sign means I have 2 sets of that bracket. So yes, they did this part right. Okay? On the bottom, well, that doesn't factor at all. All I can take is a hidden 1 outside of that. So yes, that's perfect. It stays in the bracket by itself. On the right-hand side, these are difference of squares, so you can square root both of them. So when you square root the 9, you get 3 starting. Square root the 16, you get a 4 at the end. Okay, both of those are correct. Same on the bottom. Square rooting 25, you get a 5. Square rooting 36, you get a 6. Those are both correct. On the right-hand side, they had to flip it, and there's nothing that they factor into. Those are both correct. So all the factoring stuff is correct. Now what did they do? Let's see if they canceled what they were supposed to. So, this 3c minus 4d on the bottom here is going to cancel with the 3c minus 4d. That part's correct. Then I've got a 3c plus 4d. That guy's correct. Then I've got a 5c minus 6d on the top and the bottom. Those are correct. You're left with this and this. So all the canceling is correct and their answer is correct. Let's check the non-permissibles. What are the non-permissibles going to be? So let's take a look at what it would look like. The non-permissibles, remember, are going to come from, I'll show you, all of these and this top one. How come? Because he was originally on the bottom right here. Okay, he was originally on the bottom. So all of these bottoms and that top right one are what I need non-permissibles for. So let's take a look at what this first left one is. If I go 3c minus 4d equals 0, I've got to take the 4d to the right. So I add 4d, add 4d. Can you guys shut the door, please? Okay, so now we're going to take a look. I get 3c equals 4d's. Divide by your 3, divide by your 3. So we should have a c, and that would make it a 0, right? So c can't be 4d over 3. Do I have that over here? I have a positive 4d over 3. I've got the positive 1. Yep, that's correct. That's that first bracket. Okay, this guy's done. Now I'm going to look at the next two brackets. These two are identical, and they're identical to the one on the top right. So that means that these three, I'm going to solve, and they'll be the same answer. Okay? So if I take 5c minus 6d equals 0, and solve that one, plus 6d's plus 6d's, 5c equals 6d, sorry, 6d, not 6cd, 6d, divide by the 5, divide by the 5. Okay, so c also can be 6d over 5. Perfect, excellent. Okay, now we got to do this very last one over here. Okay, that very last one over there. Well, when I take the 4 across, it's going to become a negative. So you get negative 4d. On the bottom will be a 3. Negative 4d over 3. Was there any error in that one? No, this one was done correctly. So sometimes there are not any errors. You have to check absolutely every step. Okay? Any questions left?
Yeah.
Yes.
On the second row,
Yeah.
when we factored out 25c squared minus 36d squared, it should be
Oh, that's the error.
plus minus.
Oh, aren't you smart? Good girl. There is an error. Right here. Look at this guy. We have a minus. Whenever we have a minus, let me erase some of my scribbles here. Whenever we have a minus, you guys, it has to give us a positive negative. Right here, so this answer right here has to have a positive and a negative. They're both negatives. One of them's got to be a positive. That's the error, and that's going to make things very different for us. So that means my bottom number that's still there, so my solution is not correct. That should be a 5c. But let's go back now. We have to go back. Oh my goodness, let's try this again. Let's back up a step. Let's back up a step. Well done, kids. Look how smart you are. I usually don't put these find an error if there's no error. Okay. So this guy now, this is going to be a positive down there, which makes this guy a positive. So what else cancels, guys? One of those and that bottom. So you won't have a bottom left anymore. And you don't have this guy there anymore. You only have this as a possible answer. Okay? So that does change things big time. And it changes what can be your non-permissibles as well. So this non-permissible is correct. That non-permissible is correct. But because that's a positive now, that positive, when I solve him, 5c plus 6d equals 0, he's going to become a negative on the right-hand side. Over here, I've only got the positive one. They're missing the negative one. So another non-permissible is missing. The negative 6d over 5 is missing. Okay? Well done, folks. Okay, so that was missing, and our answer was incorrect. We could cancel more things out. Very nicely done. Okay, now we're going to have some practice time. So all of our examples, hopefully you've realized by now why we have to come up with non-permissible values from our original solution. Because if we look at that last question, did we end up with a denominator at all? No. So if we actually found our non-permissibles from our answer, there would be none. There'd be none because there's no denominator left, and there's no variables in a denominator. But there are non-permissibles. Non-permissibles are from the first factored form. Okay? So if we do it the other way, we get no non-permissibles, which is totally incorrect. So this is what we have to write down. And I know it's a bit, but you need to have it. So, the simplified form of a rational expression may not be in the factored form, and it might be mistaken for having no non-permissibles, which could be incorrect, which is what we just saw in that last example. There was no fraction. We didn't have a bottom. So that's what number 1's telling us. It's like the question we just did. There was no bottom left over, so our answer looked like there'd be no non-permissibles, but there actually is. Okay, I'll just give you a minute to write that down. Okay, last couple examples here. Again, every form we've been looking at has pretty much given it to us in factored form. Why do you think we reviewed our factoring? Because this is the format they usually give it to us in. So we now have to factor every form before we can simplify it. So let's take a look. We're going to do our diamond on these guys. Hopefully some of these you can visually look at right now. And hopefully on the top one you're looking at it and saying, okay, well 4. What are the factors of 4 that add to 5? Well, 4 and 1, correct? So you would have x plus 4, x plus 1. Okay, that's the left-hand side of my top. On the bottom, they all divide by 2. So divide your bottom by 2 first. Then we get an x squared minus 4x plus 4. Okay, we're going to further factor that in a moment. Then we're going to factor the right-hand side of that expression. And on the right-hand side, what is the common factor in the top that I can divide out? What do they both divide out? 4, good. They both divide by 4. So I'm going to get x subtract 2 on top. And what does the bottom make? What do you notice I can do with the bottom? Square root, good. So I'm going to get x minus 1 and x plus 1. Okay? There's no division, so I don't have to flip it. But now I still have 1 left to factor. I have to factor that bottom left still. So what multiplies to 4 and adds to 4? 2 and 2, right? But this guy's a negative in the middle, so they both have to be negatives. So this bottom over here now is going to be this. 2x minus 2 and x minus 2. Okay, so this is no longer our bottom. That's the bottom we're looking for. Now that it's in factored form, we're going to find non-permissibles. So the non-permissibles on the left-hand side, the red ones, what would those be? What would make those brackets 0? Positive 2, good. So x cannot be positive 2. What else can x not be? Look at the right-hand side. Plus and minus 1. Good, so x cannot be also plus and minus 1. Okay, so we've got our non-permissibles. Now my favorite part, start your chop and start cutting it back, guys. So what can cancel? What can I wipe off? The plus 1 on top and the plus 1 on the bottom. What else? The minus 2 and the minus 2. Anything else? The 4 and 2 reduce. Both divide by 4. Or sorry, both divide by 2. Okay? That's all that reduces. Now you write what's left over side by side. So on top I have a 2 left over and an x plus 4 in brackets. On the bottom I have left over an x minus 2. Okay, now don't get crazy on it. Start taking those 2's away because they're both 2's, top and bottom. Remember, that 2 on the bottom is in a bracket. He's a binomial. He's attached to that x, so you can't get rid of him. Okay, so this would be our final answer. Oh, we're missing x minus 1. Good thing you guys are on the ball today. Look at you go. X plus or minus 1 is also on there. I almost forgot the x minus 1 here. Don't forget. Okay, so that's all that's left over. That is now my final answer. Okay? You guys try B on your own, okay? Take a couple minutes to try B. Okay, you have a couple minutes to look at these. Let's see what your factoring is. So first of all, I'm going to flip this guy when I factor him, okay? So I need a lot of space to write. So I'm going to have 2 coming out. I get an x minus 5. That's this guy taken care of. The bottom is my x plus 3. I'm going to times by the flip of this guy. I'm going to take a 2 out. Then it becomes x squared minus 9. And those are perfect squares. So I'm going to open 2 brackets and have x minus 3, x plus 3. On the bottom will be this guy here. I'm going to take out a 4 first. And when I take a 4 out, I'm going to get, or sorry, 3 out. I'm going to take a 3 out, not a 4. They all divide by 3. If you have a GCF, you can divide them all by 3. So you're going to get 4x squared, 20x, and a 25. So now when you do the diamond on that guy, you've got a times c, 4 times 25 is 100. Your middle is a negative 20. Well, what multiplies to 100 and adds to 20? 10 and 10. But they've both got to be negative. Now you've got to factor the 4. Now, are you going to use factors of 1 and 4 or 2 and 2? 2 and 2, because 4 doesn't divide evenly into 10. So you're going to use 2 and 2. So these brackets are going to both start with 2 x's. Now, we divide them both by 2. They become 5s. So I'm going to have a minus 5 and a minus 5. Okay? Yeah. Yes, thank you very much. Excellent way to catch another error of mine. You're on it today. Okay, now we're ready to cross cancel. So, 2x minus 5, 2x minus 5 disappears. Your x plus 3, your x plus 3 disappears. Nothing else disappears. So now you're going to have left over 2 times 2 gives us 4. And on the top, you've got an x minus 3 left over. On the bottom, you're going to have a 3 left over and your 2x minus 5. Okay, final answer. Let's look at our non-permissibles. Remember, we did flip it. So with your non-permissibles, the only one that you don't use for a non-permissible is this top left-hand one. We don't use that guy. But we need to use all of the rest. So on the bottom left, what can x not be? Negative 3. On the top right, positive and negative 3. So first of all, we know that x can't be positive and negative 3. What else can't it be on the bottom here? Positive 5 over 2. Okay, so there's our non-permissibles. Final answer. Check your work. You see a lot of these problem-solving questions, and I've seen one like this on the diploma. So this one says, you have a box that has a volume of 2x cubed minus 10x squared plus 12x. And it's got a height of 2x and a length of x minus 2. What is your width? We need to know that any box has a volume of length times width times height. Okay? Well, we're told what the volume is. So we're told that we've got 2x cubed minus 10x squared plus 12x is our volume. So that's the left-hand side of my equation. On the right-hand side, I have a height of 2x and a length of x minus 2. So I've got x minus 2 and a 2x, and then I've got a height. I need to solve for height. I have no idea what the height is. But I know something times those other 2 brackets is going to give me all of that on the left.
Are we looking for the width?
Wow, I'm so on it today. You are right. We're trying to find width. It even tells me right there. Okay. We're trying to find the width. So, now what we've got to do, how do I get everything on the right-hand side that's sitting beside that W to get it to disappear on the right? You divide it because it's sitting side by side, which is multiplied. Get rid of it, you divide. Do the opposite. So I'm going to divide both sides by what's sitting beside my W. So I'm going to divide by x minus 2 and 2x. They disappear on the right-hand side now, and all I have left is my W. I'm looking for width. So that means on the left-hand side, I'm going to do the same thing. I'm going to have x minus 2 and a 2x. So basically, this is my expression that they're telling me to solve. Now, they could have given it to me in an expression just like this. They didn't want to. They wanted to say, here's a problem-solving question. Let's see if you guys know how to put it together. Okay, that's all they did. So we've got volume on top of length and height. We're going to find the width. So the first thing we've got to do now is we have to factor our top. Top isn't factored yet. We can't start until everything's factored. So I'm going to have a 2x coming out because I have a greatest common factor. I can divide all of the top by 2x. That's going to end me up with an x squared minus 5x plus 6. Okay, now it's a trinomial that I can actually factor. And again, my bottom stays the same. It didn't change. My bottom is still x minus 2 and 2x. Now I've got to factor that top even further so that I can cancel things out. So what does that top factor into? If I do the diamond on what's in the bracket there, the x squared minus 5x plus 6, what multiplies to 6 and adds to 5? 2 and 3. So my brackets become this. They're both negatives because the 5's a negative and the 6 is a positive. That's why they're both negative. So you're going to have x minus 2, x minus 3, all on top of the bottom you have. X minus 2 and 2x. Okay? So what is the non-permissible value of my denominator here? What can x not be? Positive 2. What about this bracket? 0. So we know x cannot be 2 or 0. Okay, we know that for sure. Okay, let's start canceling. X minus 2 disappears. My 2x disappears. What do I have left over? X minus 3. So I'm going to get my width equals x minus 3 because that's all that's left over on top. Okay? Any questions with that? No? And that's all you would say. You'd say, okay, my width is x minus 3. Done. Now, the only thing you could do further to this question is if they said now and did a second part of the question and said, okay, what if the x is 15? What are the dimensions of that box, length, width, and height? Then you would put 15 where x is in each of the length, width, and height, and you'd solve each of them. That's the only other thing that they could do a question like this. Okay? Any questions? No? Okay, this concludes 2.2 multiplying and dividing rationals.